All right, let's practice just a couple more. So we have this exponential function, and we know it goes through the point -324, and it also goes through the point 1/2 68. Okay, and so we need to find it when x equals -2.5. So first thing we do is we write the standard form of an exponential function, and then we plug in what we know. We find we have two different equations that we know are true. Okay, the first one we know when y equals, I'll say it the right way, I'll say it backwards this time so that I can write it. When y equals 24, x equals -3. So we know that's true. We don't know what a and b are, but we know that whatever a and b are, this ends up being true. And then we also know that then y equals 68, x equals 1/2, or 0.5. So here we have two equations with two unknowns. We can use substitution to solve them. So it doesn't really matter which one you want to use, but I think let's use the red one because it's slightly simpler when we solve for a. So we're going to divide both sides by 20, not by 24, by b to the -3, b to the -3. And so I have 24 over b to the -3 equals a, but what is that b to the -3, right? Remember, negative usually means you put it in the denominator. Well, it's already in the denominator, and so there's this little mnemonic that I say sometimes, like cross the line, change the sign. So here it is in the denominator as a negative, and so if I bring it up to the numerator, it becomes a positive exponent, and then yeah, it's just up in the numerator. So that's b cubed equals a. Okay. So we're going to remember that a equals 24b cubed, and we can put it in here for a. So we're going to have 68 equals 24b cubed times b to the 1/2. Okay. Now remember, when we multiply two things with the same base, we can go ahead and just add their exponents. So this is 24b to the 3.5. Divide both sides by 24, and I'm going to get b to the 3.5 equals 68 divided by 24, which is 2.833. And then I need to get rid of that exponent. So to get rid of 3.5, I have to raise it to the 1 over 3.5 power. Okay, because I want those exponents to cancel out. And if I raise that to the 1 over 3.5 power, I also have to raise that one. Now remember, when I multiply these two exponents, those are going to become 1, and I'm just going to end up with b. And then I have 2.833 to the 1 over 3.5 power, so to the 1 divided by 3.5. Okay, so I get that my b value is about 1.346567. So I'm going to store that in my calculator. If you're using a graphing calculator, store it under maybe b, so that we can come back and check it, because that's actually really cool to see. So we have b here. We need to know what a is. Well, a is 24b cubed. So all I have to do is take b, cube it, multiply by 24, and I get a. A is 58.599642. Okay, so I have these really hairy numbers, and they feel just ridiculous. Now, again, you want to store these in your calculator because we need to use them. Because here we have y equals a, which is 58.599, times b, which is 1.3, I'm not going to be able to fit it, 46 to the x. So this is our new function that we're working with, and those numbers are really hairy. So we're going to store them in our calculators, a and b, and then we want to calculate the value when x equals -2.5. That's what this says right here. It says find f of negative 2.5, which means I plug into negative 2.5 for the exponent. So, yeah, let's just go ahead and do that. Then I'll show you something else. Okay, so you take your stored value, that 1.34 value, and you multiply it, or you don't multiply it, you raise it to the negative 2.5 power, and then you multiply it by that other stored value you had, and you get 27.85. Well, that's pretty. So when I plug in negative 2.5 for x, I get 27.85 for y. That's actually really cool. And you know what's even cooler is if you went and you checked, so you get this hairy thing and you're like, there's no way. There's no way. That can't be right. Well, let's go ahead and plug in negative 3 and see what comes out. So again, you take your stored value. We've got that stored value. We raise that to the negative 3 power because that's our x. Then we multiply it by our other stored value. So we go back in here for a. And guess what? Right there. You guys, oh, you can't see. I got out 24, just straight 24. Isn't that crazy? Just 24, which is what I was supposed to get out. So then you know you did it right? Because this function passes through that point. And we could put in 0.5 and find the same thing. So it's pretty cool, right? You got all those nasty decimals, and then you still can come out with something really nice. Okay, so what I love about exponential functions is that we use them all the time for word problems because basically, like, lots of stuff in this world grows exponentially. Very few things actually grow linearly. So we're just going to talk about Jack. He's a lab assistant and he's monitoring bacteria. So he starts and he measures 4 bacteria at the beginning. Then he goes to class and comes back 6 hours later and he measures 2,916. So we were trying to find the growth rate. We have an initial amount. Our initial amount is 4, so we can just put that, and then we have b to the x. We don't know what b is, but we can just put in our point, which is 6, 29, 16. We know that when x equals 6, y equals 29, 16. So we do 29, 16 here equals 4, b, which we don't know, to the 6th. We divide both sides by 4. And we get b to the 6th equals 2916 divided by 4 is 729. So b to the 6th equals 729. And then we raise that to the 1/6 power to undo the 6th. Okay, so the 6th root of 729 is 3. Ooh, that's handy. So b equals 3. So our new function is y equals 4 times 3 to the x. Now again, this is not 12 to the x. This is 3 to the x times 4. And so then you could plug in any value and you could figure out how many bacteria are going to be there at any number of hours. Okay, so he had these 2 bacteria cultures, right? And the first one he was really good, but the second one he got distracted because, you know, he's a college student and college students get distracted. So he forgot to measure the initial amount. Maybe he wrote it down on like a Post-it or something, but lost it because, you know, he's sleep deprived from being in college. Anyway, so at 2 hours, he had the measurement for 2 hours and it was 12. And at 8 hours, he measured 768. So we need to find this function still. So it passes through 2 points, 212 and 8768, right? It passes through at when x equals 2, y equals 12, and when x equals 8, y equals 768, okay? So we can just go ahead and write an exponential function, y equals a b to the x, and we can put in these 2 points. So first we can put in the point 212. So we have 12 equals a b to the 2, that should be squared. And then 768 equals a b to the 8th. Okay, so we have these 2 functions with 2 unknowns. So this is a system of equations. We're going to solve them with substitution. So we're going to divide both sides by b squared so that I can have b or a all by itself. And now I get that a equals 12 over b squared. So this is an important value that I want to make sure I remember where it is. We're going to plug that in for a right there, and we're going to get 768 equals 12 over b squared times b to the 8th. Okay, now I can go ahead and simplify this. This is really 768 equals 12b to the 8th over b squared. And so remember, two of those b's cancel out, top and bottom. So we have 768 equals 12b to the 6th. You might remember the subtraction rule would work for this too. 8 minus 2 is 6. So we can go ahead and now divide both sides by 12. So we get 768 divided by 12 is 64. So I'm going to write it over here. 64 equals b to the 6th. So we're going to raise that to the 1/6 power because I want to undo to the 6th power. And I get that b equals 2. So our growth rate equals 2, which means that this is growing at a rate of 2 or 200%, which means it's doubling. It's doubling every year, every hour. So we come all the way back up here and we have y equals, now we know b is 2, so it's doubling, 2 to the x. Well, what is a? Well, a is 12 divided by b squared, so 12 divided by 4, which is 3. So a is 3. So this is y equals 3 times 2 to the x. And that's it. We have a Delta Math assignment on this. So hopefully this gave you some really good examples on how to do these.